Hi, everyone. My name's Marguerite Lally, and I've taken over the research lab from Brett, and I've been running the lab with Jeremy Porter, the head of First Street's Research and Development. I wanted to thank you all for coming to the fourth workshop in the Research Lab Workshop series. For those of you who don't already know, we host these workshops every 3 to 4 months in order to give Research Lab members the opportunity to present their research and get feedback. So today, Joe Weill of UC Davis will be presenting his research on how prices and information influence the demand for flood insurance. Before Joe presents, Mike Amadeo, the head of data science at First Street, will discuss updates First Street has made to our data. I also just wanted to note that this workshop is being recorded, and we'll get these slide decks and the recording to you all after this. And there will be time for Q&A after Joe presents. And now I'll pass it to Mike to give you all updates on the data.
Great, thank you, Marguerite. So as Marguerite mentioned, we're kind of always coming out with new data. We've recently had a few launches that we want to tell you about. One that's kind of recent, two of them that are kind of upcoming, and new data that should be out within the next few months. So starting off, we have our community risk product, which you can see currently in flood factor. So what we've done here is quantify the flood risk based off of our flood model for different sorts of facilities within a community. So this includes infrastructure, it includes social facilities, it also includes metrics around residential and commercial properties specifically. So it's kind of a different way to aggregate and look at some of the data, the property specific data that we've created that folks at the research lab have been working with. And this was, we had a report around this that launched on October 11th, where the data went live on Flood Factor. I believe this is currently available through Esri's Living Atlas. Yes, there it is. Thank you, Marguerite. So all of this information can be found there. This sort of rating, it goes through and rates things much as we do for individual homes from minimal risk up to extreme. Now we've sort of applied a similar methodology to different geographical units, counties, cities, zip codes, neighborhoods, all these sort of different aggregations so that you can see, even if an individual home might not have risk, the community at large is going to have some amount of flood risk. So this information, as I said, is available on Living Atlas. We're also working on other distribution channels, which I guess I can let Marguerite talk about a little bit later. The next product that we're working on that has not been released yet is an average annual loss product for commercial buildings. So as you may be familiar with, we already for residential properties have released average annual loss data based on the flood model and the flood data associated with that. What we've done for this is extend that essentially out to more land uses, so that it's not just 1 to 4 unit residential. This covers several different types of commercial properties. So the residential depth damage functions were based on the HAZAS curves. What we've done now by working with Arup, a global engineering firm, is to create new depth damage functions for these other land use types. So we're looking at offices, so general commercial, which kind of aligns to retail, but includes a few other things as well. And then also multi-use residential. So we start to look at apartment buildings and things like that. These depth damage functions are built specifically around the elements that would be commonly included and damaged and what the repair costs would be for each of these use types. Next slide, please. And then, just one last note on the commercial AAL. So that data will be coming out. We'll have a report on that within the next month or so. And then the last thing that we're working on right now, or the last thing that will be released soon that we're working on right now, we're working on a whole lot, as always, is our version 2 of the flood model. So this is going to be, I believe I spoke about this with this group a few months ago and kind of gave a little bit of insight as to what it's going to include. High level, we're going to add Puerto Rico, Hawaii, and Alaska, so that we'll get additional coverage of all the parts of the country that are, parts of the United States that we didn't have before because we were just focused on the continental US. And there are going to be some other changes to the statistics and the way we go about deriving risk scores and things like that. I won't get into those details right now. But if you're working with the data, that would be a good time to make some updates, pull fresh data, and see kind of how that might impact your research results. I think that was it. Thank you, Marguerite.
Yep. So First Street has updated how we deliver data. As an organization, First Street's moved away from using the API for data access. And we have removed data access for current Flood Lab members and transitioned to a bulk data access delivery. So we discovered that after this past trial year period with the API, it wasn't as seamless as we had hoped. And we're moving towards bulk data delivery in order to expedite the research process. This slide shows what data is available. And I will also share out a link to the data dictionary so you guys can look at that. But the flood risk statistics will be delivered in CSV format through an S3 link. So if you have any outstanding data needs, you can email me and we'll make sure to get that data to you. And now I wanted to introduce Joe Weill. So Joe is a PhD candidate at UC Davis. His current research lab projects investigate the distributional impacts of the flood insurance program. And today he'll be presenting his research on the impacts of flood risk estimation. So I'll pass it to Joe now to present perilous flood risk assessments.
Thanks a lot, Marguerite, and thanks to everyone for coming here. I'm super excited to share this research. Can you see my slide?
Yes.
Great. Okay, so this is part of my job market paper. And if you have any comments or feedback, I'd love to chat more with you about it, either today after the talk, or feel free to follow up by email afterwards. I'll go a bit quickly on the motivation since you all know this, but so in the United States, households face substantial climate risks, and these risks are both evolving and really, really hard to assess. In particular, natural disasters caused more than 800 billion damages just in economic damages, not counting lives lost in the past 10 years. And there are adaptation tools that are available. In particular, insurance is available for a lot of these climate risks, but there are several barriers that may prevent adoption. And in this talk, I'm going to focus on the information barrier or lack thereof, people not knowing that they are exposed to these risks. Even when the tools are available to adapt, there can be some distributional concerns about who is going to have the means to effectively adapt to climate change. And so in this talk, I asked, how does publicly provided risk information impact the demand for disaster insurance? I'm in particular going to focus on whether information access mitigates the impacts of existing information, and also how are these effects distributed within the population. And of course, this is going to be a paper about floods, and I'm going to focus on the demand for flood insurance and how this is impacted by flood maps in the United States. This is a super important context for two reasons. And again, I think I can go a bit quickly on this slide as well. First, flooding is the costliest natural disasters in the US, but also it's a domain where the public, where the government has a lot of influence. And in the United States, 95% of all flood insurance policies are provided by the federal government, and they are largely subsidized, although there is some heterogeneity there. However, a lot of people who are at risk of flooding do not currently carry flood insurance, and this is a bit puzzling. There are only 5.5 million residential properties currently covered by flood insurance, but about 3 times that amount of properties that are estimated to be at high risk of flooding. If we believe that people do not like taking risks and that they are risk averse, then this reveals that there are frictions that limit the demand for flood insurance below its optimal level. And the lack of information about flood risk is thought to be one of them. Now, this is even more puzzling because flood risk information is available in the United States in the form of FEMA flood maps. At least the official product for a long time was the only source of information about flood risk before the great First Street Foundation flood model. And these flood maps do several things. First, they provide the risk information and show the extent, in particular, of the 100-year and 500-year floodplains. They are used to set insurance premiums. Prices are higher in the 100-year floodplain than right outside for identical properties. And there is also an insurance mandate that is supposed to be enforced, although some evidence show that it may not be enforced at all, and people might not be aware of its existence. But if you have a federally backed mortgage on your house and you live in the 100-year floodplain, you're supposed to purchase flood insurance. And this means that when I look at the impact of flood maps on demand for insurance, I'm going to have to do a bit of extra work to show that the channel is really information and not just a mandate effect. So these flood maps are out there, but it's unclear whether they are used. And these flood maps are also extremely costly. Since Hurricane Katrina in 2005, there were more than $3 billion US dollars that were invested to improve these flood maps. And one of the goals to modernize these maps was to increase flood insurance take-up. I mean, $3 billion for mapping, that makes it the most expensive cartographic effort in recent history. To get a sense of what these old flood maps looked like before the modernization, I took here some pictures for Upper Merion County in Pennsylvania, where Hurricane Ida led to several casualties recently. If you wanted to know your risk exposure on your property, you first had to find the map index for the county, here shown on the left, A. And once you figure out which specific panel is showing the section where your house is likely to be, you go and get this panel, and it's shown here for a specific panel on panel B. And you can see that it's pretty hard to figure out if you're located inside the 100-year floodplain in gray or right outside of it. And you have like these lines that represent streets, but are overall pretty complicated to interpret. Oh, sorry, I just need to turn this off. After the modernization, this is what the flood maps look like, the official FEMA flood maps. They are now consolidated in an online platform, the National Flood Hazard Layer, where you can just put in your address here. And this is going to drop a pin on your home that is going to show you whether you're inside of the 100-year floodplain in blue, in the 500-year floodplain orange, or outside of the floodplains altogether. So these modernizations of flood maps, they did two things. They either just digitized boundaries that were already there on the paper-based maps, or they digitized and in some cases modified the extent of some floodplain boundaries. And here, this section here was added on the recent map for Upper Merion. So when new maps rezone properties inside of the high-risk zone, inside of the 100-year floodplain, the effect on the demand for insurance is a priori ambiguous. And this is so because the flood map updates that rezone properties toward the 100-year floodplain is going to increase the price of getting insured for that property. And this should reduce the demand for insurance if we believe that insurance is a normal good, which is not a crazy assumption. But this is also going to increase the perceived risk of the homeowner who lives in that house, and this should increase the demand for insurance. So really two competing effects. Now you can also think that, well, this might increase, that this might make the insurance mandate binding for that household. And if that's the case, this is also going to increase the demand for flood insurance. And so a priori, the effect on the purchase decision is going to be ambiguous. So what I do is that I'm going to combine new data on all flood maps that were modernized by FEMA over a 15-year rollout. And to study the effect of pure information access, I'm going to focus on communities that digitized flood maps, but did not change the underlying floodplain boundaries. On the other hand, to study the effect of new risk information contained in the map, I'm going to focus on places where the new maps really change these floodplain boundaries. And I'm going to leverage difference in the timing of these map updates between communities over space to estimate the causal impacts of the maps. I won't have time to go through all of the results. They are in the paper if you want to go see them, but I'm going to quickly preview what I found in this project. And the first surprising thing was that over the past 15 years, the modernization of flood maps rezoned more properties outside of the 100-year floodplain than inside of it. And on net, I found that more than 1 million properties were removed from the 100-year floodplain, which is a bit surprising given that I thought that, yeah, with climate change, I expected more properties to be at risk. I also find that households are extremely attentive to the 100-year floodplain classification. When they are zoned inside the 100-year floodplain, their demand for insurance increases. When they are rezoned outside, they drop their insurance coverage. But when there is no change in the floodplain boundaries and the new flood map is just a digitization of the previously available product, I don't find any significant impact on take-up. I find some interesting spillover effects, meaning that households are more likely to purchase flood insurance, even if they are not rezoned in the 100-year floodplain, as long as adjacent properties are rezoned in the 100-year floodplain, which means that households pay attention not just to where they live, but also to where their neighbors live relative to the 100-year floodplain. I also find that these effects are very unequally distributed. Most of the declines in insurance take-up induced by the maps occurred in neighborhoods with a higher share of African Americans, which raises some concerns regarding the vulnerability of these neighborhoods to flood risk. Finally, to get at the welfare effect, so whether these maps updates were a good thing or not, you need to make a lot more assumptions, in particular on risk preferences and on information accuracy. And that's where I'm going to compare the FEMA flood maps with the First Street Foundation flood models, which suggests that, in fact, 2/3 of the previous reasoning were correct, but a lot of reasoning should have occurred, yet didn't. And on aggregates, I find that these map updates nationwide decreased insurance updates. So really an unintended effect of this policy. I'm going to skip a little bit the contributions to the literature, just because I want to make sure we have enough time for the Q&A afterwards, but I'm happy to go back to this if there are any questions. Okay, so this is a data intensive project. So I'm going to present the different data sets here and how I make them fit together. So first, to look at how these floodplain boundaries evolved, we need to have a digital version, a shapefile version of flood maps that were effective before the modernization. And this is given by the Q3 data product, which was a very early attempt by FEMA to provide a GIS-ready version of the paper-based map. So you just have the floodplain boundaries that have been digitized there. And I'm going to combine this with data I got from archives of contractors who worked with FEMA, and also corrected by some information I scraped from the FEMA map service centers that gives information on the extent of the different floodplains in each year. And when I combine these three things, this allows me to really show how floodplain boundaries in the FEMA flood maps evolved through time, when did they evolve, and what were the reasoning that occurred. And I'm going quickly on this, but just getting these data took about 2 years, and then it took more like about a year of cleaning afterwards. Okay, so now we can see where these boundaries change, but we only care about changes in floodplain boundaries where people live. And so to get at that, what is this? Can you see, is it full screen still or no?
No, it is.
Okay, great. Thanks. Sorry about that. So to get at where people live, I use the repository of geolocalized residential properties by the First Street Foundation. And I intersect this with each of the flood maps and how they evolve to get at floodplain rezoning at the individual property level. Now I care not just about floodplain rezoning, but how this rezoning impacted the demand for insurance. And so I get the insurance data from OpenFEMA, but also through a couple of FOIA requests that I put in to have access to the earlier insurance policies at the census tract level. And one issue there is that the flood insurance policies are not identified down to the property level. Even after several FOIA requests, FEMA didn't want to provide this information. So I only have it at the census tract level. And I spent about a year trying to merge these census tract level policies data to individual properties. And this merge just doesn't work. I'm happy to talk more about that as well. So what I do is that I create a data set at the census tract month level to get a sense of the number of active insurance policies in each census tract, sometimes each floodplains, the premiums in the census tracts, etc. I'm going to combine this with additional information at the census tract level, and in particular, occurrence of natural disasters from the shelters database, NFIP claims, etc. And I'm going to talk a bit more today about what I do to compare the individual rezoning at the property level with the First Street Foundation flood model to really get at a sense of better flood risk estimates and whether these flood map updates were correct or not. This is what the rollout and of the treatment of the new flood maps look like. On panel A, here you have time on the x-axis and the number of census tracts that are covered by a flood map on the y-axis. In blue, I'm showing the census tract that get their first digital flood map. And a lot of these start to occur after 2007. And by the end of the sample period here, almost all census tracts have a digital flood map, but not all of them. You can see in panel B that in the Midwest, where population density is lower, we are still missing some digital flood maps. And in green, I'm showing census tracts that received two flood maps and two digital flood maps. And that's a very small minority of census tracts. If we zoom in on a particular community, here I'm showing New Orleans. So you have the city park here. This is the French Quarter. If you've been to New Orleans, amazing place. So I'm showing in panel A, the map that was effective in 1984 and which remained in force until September 2016, when New Orleans received in panel B its new digital flood map. Each black dot is a residential property. The blue areas are the 100-year floodplain. Orange is the 500-year floodplain. And in pink, you have the areas that are protected by levees. And what is immediately apparent here is that there was a lot of rezoning outside of the 100-year floodplain. All these areas here that were blue are now orange, meaning a decrease in nominal flood risk, or pink outside of the floodplain altogether. And so I'm going to do this and measure these changes first at the property level, which I show in panel C here. All the properties that are red were removed from the 100-year floodplain. You have a few blue properties here that were added to it on the new map. And I'm going to aggregate these changes at the census tract level to assign a classification to the census tract and whether it was a decrease in the 100-year floodplain overall at the census tract level, an increase, no change, etc. I'm doing that for all the properties that received a new flood map and for which I can assign the older flood map status. So I'm showing here the Southern Broward County, where you have both increases in the middle here and decreases in the 100-year floodplain overall. And when you look at the entire nation, you find that most states have both increases and decreases in the extent of the 100-year floodplain depicted on the flood maps. Some places have more of like one direction or another. For instance, blue here in the Appalachia region, these are places that were rezoned towards the 100-year floodplain on the most recent maps, but a lot of rezoning outside of the 100-year floodplain occurred, in particular in Florida on the East Coast, Louisiana here, Texas. And overall, more than 1 million properties were rezoned outside of the 100-year floodplain. Each time there were massive rezoning outside of the 100-year floodplain, the FIS studies explained that it was due to either new adaptation infrastructures or improved mapping technologies. I'm not going to take a strong stance on whether these rezoning were warranted or not, whether there was lobbying or not, but I'm going to compare these official changes with what the First Street Foundation flood model says for these properties. Very quickly, just to get a count on how like the mapping process was able to provide flood risk estimates for more properties. Here I'm showing on the first column, these are the number of properties that were mapped in about 2005 were on the Q3 product. There was about 80 million properties outside of the 100-year floodplain at this time, and about 7 million properties a bit more inside the 100-year floodplain. And 45 million properties were outside, they were not mapped at all in 2005 from this Q3 product. Now, if you flash forward to 2019, 30 million more properties now have a digital product, but 500,000 less properties are mapped inside the 100-year floodplain. So there was a lot of mapping that occurred, but this mapping did not translate in adding additional properties to the 100-year floodplain. Now, if we look at what happened at the property level, specific changes that occurred at the property level, and comparing this to the First Street Foundation model, I find that many of the changes were actually correct. And in particular, there were like 500,000 properties that were added to the 100-year floodplain when the FSF model says they should have been added. And among the properties that were removed, 1.7 million properties were correctly removed, meaning that they were shown inside the 100-year floodplain on the old flood maps, outside the 100-year floodplain on the new digital flood maps, and also outside of the 100-year floodplain on the First Street Foundation flood model. There were some incorrect changes, about 1 million of them. But the big issue with this official FEMA mapping process was that it ignored a lot of properties that should have been added to the 100-year floodplain. Here in the areas that had a Q3 data product that received a digital flood map afterwards, there were 5.2 million properties that were outside of the 100-year floodplain, where the First Street Foundation flood model says, well, these properties should really have been added to the 100-year floodplain, sorry. Okay, so now I'm moving to the estimation part and trying to understand what these mapping did to the demand for flood insurance. Very quickly, the standard approach to doing this like 3 years ago would have been to do a two-way fixed effect models. It's not great to do that anymore when treatment is staggered, meaning that different places receive treatment, the new map at different points in time. And I have a paper with some great co-authors showing that you can even get the wrong sign when you use two-way fixed effect models in this case. The new approach to doing this is to estimate average treatment effects separately for each cohort. So for groups of census tracts that receive their digital flood maps at the same time, and then reaggregate. And here I'm going to estimate these effects using as control units the census tracts that have not yet received a digital map at the time of the treatment. I'm also going to separate these estimates based on the direction of the change in the 100-year floodplain. So I'm going to estimate the effect for places that saw an increase in the 100-year floodplain, a decrease, or no change in the floodplains altogether. When you do this, I'm showing the results here for two outcomes, the number of active insurance policies in blue, and I'm using an inverse hyperbolic sine transformation, which is a bit like a log, and also the average insurance premium in the census tract. If we focus on the first panel, these are census tracts that were treated where the digital flood map reduced the number of properties in the 100-year floodplain. And you can see that this translates into an about like 10% decrease in the demand for insurance after 2 years, looking at the blue line here. In contrast, where you look at places that increase the extent of the 100-year floodplain, you see this massive increase in the demand for insurance of about 30%. And places that didn't see any change in the floodplains with the new map, either in the 100-year or in the 500-year floodplain, I find no clear significant effect. And so this tells us that risk information has large impact on demand, but also that the mode of information provision, so just digital versus paper-based, does not really matter. And I'm not going to go at length about discussing the price responses here because price is an equilibrium outcome because I measure average prices at the census tract level. But you can see that these changes in demand cannot be explained by changes in prices because they tend to go in the same direction. These effects are aggregated over like all the cohorts. So there are about 115 cohorts that received digital maps at different times, but this is the picture you tend to see if you look within each cohort. And I put some of these pictures in the paper. Now, I still need to show that, well, it's not all explained by the insurance mandate in the 100-year floodplain. And for this, I look at spillover effects. And so this is a bit of a complicated picture, but here the outcomes are the number of insurance policies covering properties in the 100-year floodplain in purple, or outside of the 100-year floodplain in blue, where the definition of the 100-year floodplain is taken not from the flood maps, because I cannot match each individual property to each insurance policy. But this definition is taken from the insurance policy data that tells me whether the policy that is being contracted was contracted in the 100-year floodplain or outside. I'm showing two different treated samples on the picture. On the left, these are census tracts where there was the new map increased the extent of the 100-year floodplain and also decreased the extent of the 500-year floodplain. That was the majority of census tracts. And on the right, I'm showing places where there was an increase in the extent of the 100-year floodplain and no change in the 500-year floodplain. And there were a lot fewer units, which is why there is a lot more noise in the estimates. As expected, we see that there is an increase in the number of policies contracted in the 100-year floodplain. And again, this is just mechanical because there was an increase in the spatial extent of the 100-year floodplain. The surprising thing is that we also see an increase in demand from properties that are located outside of the 100-year floodplain. And some of them were located in the 500-year floodplain, but we still see increase in demand for insurance in these areas. So this really indicates that people are not paying attention just to their own flood risk designation, but also to what happens around them in terms of reasoning toward the 100-year floodplain. Okay, so this is great, and I hope this somewhat convinces you a little bit that there is a demand response to these new flood maps. Now I wanted to dive more into the heterogeneity and where are these changes coming from. There are three things you might be worried about with the previous estimates. The first one is that the control groups that I used, looking at all the census tracts that are not yet treated, might be imperfect to estimate the response on the treated units, the ones that receive the digital flood map. And they can be imperfect for several reasons, but in particular, there were two big flood reforms in 2013, 2014 that changed insurance premiums for a subset of policies that covered pre-firm properties in particular, or like primary versus secondary properties, etc. And so we might want to also control for these characteristics at the census tract level to make sure that when we compare the outcome for treated units and control units, we are comparing apples to apples and not apples to oranges. There are also other things that impact demand for flood insurance, like in particular the occurrence of natural disasters, and we might wish to control for that. The problem is that we can't really control for this in a straightforward way when we do the estimation by cohort, when we are looking at all the census tracts that receive a new digital flood map in August of 2012, for instance. That's not a lot of census tracts. And if we try to break down this in smaller groups, looking at census tracts that have similar shares of pre-firm properties or primary residence properties, etc., some of these groups are going to become way too small, and we can't estimate average treatment effects when there are very few units. The last point is that after talking to local policymakers and floodplain managers, well, turned out that they didn't really care about the average treatment effects. They really wanted to know what happens in their specific communities as a result of the flood maps. So what I'm going to do to get at this is to estimate census tract specific synthetic controls. I'm not going to dive into the details here, but very quickly, the idea is that for each individual census tract, I'm going to construct a weighted average of other census tracts that are not treated, that do not receive a digital flood map, where these weights are chosen optimally, such as to reduce the discrepancy between the census tract that do receive a flood map and this synthetic control. Here, I'm showing this procedure for only 6 census tracts. The first 2, for instance, 12, so they are in Florida, this is in New York, this is in Texas. You can see that the synthetic controls closely match the treated units prior to treatment, which is this vertical line here. Time is in month on the x-axis. And after treatment, these are the estimated treatment effects, dynamic treatment effects, so meaning the impact of the updated map on the demand for insurance. And in this specific census tract, you can see that the new map is estimated to have decreased the demand for insurance by about 300 insurance policies. In the same counties, the effect can be of the opposite sign, and you have here in this other census tract an increase in the demand for insurance. So there are a lot of details that I'm leaving under the rug that I'm happy to talk about during the Q&A. But I'm going to conduct this estimation not just for 6 census tracts, but for 6,000 census tracts that received the digital flood map during my observation window and that have a sufficiently large number of insurance policies. What's really cool when you do this is that you can actually see where the effects you estimate are coming from. And here I'm mapping this synthetic control estimates, so the causal estimates of the impact of the new map on the demand for insurance to specific neighborhoods here in New Orleans and here more broadly on the Texan coast and Louisiana here. Both areas that were hit by Hurricane Laura and Ida recently. In blue, I'm showing treatment effects that are positive, meaning an increase in demand for insurance following the new map. In red, these are treatment effects that are negative, so a decrease in the demand for insurance. You can see that there is a lot of heterogeneity, but in New Orleans, most of these neighborhoods decrease their demand for flood insurance following the new map. And some of these reductions can be quite large. These big dots here are more than 100 insurance policies decline in the demand for insurance. Because I'm able to connect these treatment effects to each neighborhood, I can then investigate the heterogeneity in treatment effects, which I do in the paper. And I find that most of the declines in insurance demand are really concentrated in neighborhoods with a higher share of African Americans. And this is not explained by income, but this is explained by the fact that in these neighborhoods, the new maps tended to remove properties from the 100-year floodplain. Okay, so another question that we're interested in is whether consumers also respond to inaccurate information. And for that, we need to make some assumption about like, when is the information correct, when is it not? I'm going to use the First Street Foundation flood model to assign the truth. So meaning if there was a a reasoning outside of the 100-year flat plane and the first fit foundation model finds that this property is not in the 100-year flat plane, I'm going to count this as a correct reasoning. Whereas in the other way, if it was inside the 100-year flat plane on the first fit foundation model, I'm going to assign this as an incorrect reasoning. So there is a lot going on in this picture, and it's going to be the last picture I show before the Q&A. On the x-axis, I'm showing the relative change in the number of properties that are rezoned outside of the, or inside or outside of the 100-year flat plane. So for instance, minus 0.5 means that the new map decreased the insurance property, decreased the number of properties in the 100-year flat plane by 50%. Whereas 0.5 here means that we had an increase of 50%. 50% of properties in the census tract were rezoned towards the 100-year flat plane. There are two different colors, which may not be the best choice of colors, but I can figure this out later. In purple, I'm showing places where most of the reasoning were correct based on the first fit foundation model. And in pink, these pink dots here, these are areas where the first fit foundation says that most of the reasoning at the census tract level were incorrect. Each dot here is an estimated treatment effect that I estimated through synthetic control. And this is showing the impact of the flood map updates on the demand for insurance at the tract level 2 years after treatment. So there's really a lot going on here. And I'm showing these estimates relative to the number of insurance properties. So if we just look at these dots here, this means that in this census tract, so it's a purple dot, in this census tract, 100% of the properties were rezoned outside of the 100-year flat plane. And this dot is purple, which means that most of these reasoning were correct based on the first fit foundation flood model, if you believe this model, which I think is a totally fine assumption. And the effect that I estimate on the y-axis is about 0.3, which means that in this census tract, this map update caused the demands for insurance to drop by about 30%. And you can see that overall, there is almost a linear relationship between the rezoning and the treatment effects, meaning that the more properties you rezone outside of the 100-year flat plane, the more negative the effect is going to be on insurance demand. But the effect is not substantial, is not quite different whether you look at places that had a correct reasoning in purple or incorrect reasoning in pink, which means that people seem to mostly respond to the official 100-year flat plane classification and not so much to individual information that they may have. I'm showing the results in two different areas, places that had a FEMA declaration, disaster declaration in the past 3 years, or did not have a disaster declaration, just because we are worried that this might impact the response. And I'm showing that the effects are very similar for these two groups of census tract. So yeah, basically people respond to the 100-year flat plane. The more reasoning outside of the 100-year flat plane, the more people drop their insurance. But whether these reasonings are correct or not based on the first fit foundation flood model doesn't seem to matter much. Okay, now for economists, we are also concerned about welfare, which means whether these map updates were a good thing or not. And if you want to get at that, you need a lot more assumptions. A fairly innocuous assumption is to assume that the first fit foundation flood model is the truth, so that it gives you the correct zoning in terms of 100-year floodplain, but also of expected flood cost. And I'm going to use the AAL's data from the first fit foundation model to get at that. You also need to assume some specific functional forms for household preferences, how they deal with risks. And you need to assume how the distribution of risk is distributed within census tracts. And in the paper, I show like how, if you make these assumptions, this is enough to identify the distribution of changes in consumer welfare from the synthetic control approach that I presented just above. And what's interesting is that if you make these assumptions, you can get at welfare not just at an average change in welfare overall for the entire country, but you can get at welfare changes at the neighborhood level, which means that you can focus on specific areas that might be of greater interest for policymakers. And I'm going to skip to the conclusion. So very quickly, we started in 2005. Many people were flooded, or worse, did not have flood insurance. There was a lot of money put into modernizing the flood maps, more than $3 billion through the map modernization and then risk mapping program. These programs tended to rezone a lot of properties outside of the 100-year floodplain, and this led to further declines in the demand for insurance. Now, these declines in themselves are not necessarily bad. That depends on the risk preferences of the people who live there, and also whether we think that these new maps are correct or not. And to get at whether these maps are good or not, you need to make these additional assumptions. But overall, I find that households are extremely sensitive to new risk information contained in the flood maps, and in particular, the classification inside versus outside of the 100-year floodplain, which is a really coarse classification compared to what we're able to do now with the First Street Foundation model. But also that people don't look just at their own status, they look at what happens to the zoning of properties that are located around them. And I'm still working on the sensitivity analysis for the welfare calculations to look at how the welfare effects were distributed in the broader population. Thanks a lot for your attention, and I look forward to your comments.
All right, thanks. That was an excellent presentation. Sorry, Mark, I heard you jump on.
Go ahead, Jeremy. I just was saying.
No, I was gonna say it was terrific. Yeah, it was a really good presentation. And I think, like we set time open until about 1:30. We certainly don't have to use all that time, but the rest of the time is sort of open for question and answer. So if anybody has questions about the presentation, I think now's the time to raise them. Did a tremendous job of explaining it. There's no questions. I think
everything is crystal clear.
Yeah, well, one of the things that we had a question about was the synthetic controls that you created. I didn't quite follow the process that was used to create those controls.
Yeah, yeah, that's a really fair question, and I went really quickly on this. So the idea is that to estimate a treatment effect, so to estimate the effect of the map on the census tracts that receive this new map, we need to make some assumptions about what would have happened to demand for insurance in the census tracts that received this new map in the absence of the new map. So basically, make some assumptions about the potential outcome of these treated census tracts if it hadn't received the new map. One of the standard assumptions that people do is to say, well, these census tracts would have behaved exactly as the census tracts that have not yet received a digital map. And so if I compare the outcome of the census tract that received the new map and the census tracts that do not receive a new map, then when I estimate differences in these outcomes, I can get at the treatment effect. Mm-hmm. And this is the assumption I make for the estimates that I presented before. Now, in many cases, the treated census tract, the treated units, is not directly comparable to the census tracts that do not receive a digital flood map. And if you just compare the outcomes between census tracts that receive a flood map and all the census tracts that do not, then you're going to compare things that are not easily comparable. And to deal with this situation, I'm using this synthetic control approach, which was initially intended for settings where you have a very small numbers of units. And the initial application was that you had only one unit that receives treatment. And one great example is one of the first applications of the synthetic control is when people were trying to estimate what was the effect of a tax on cigarette sales in California. And so in order to do that, well, you can look at what happens to cigarette sales after the tax is passed in California and compare this to what happened to cigarette sales in the other states. But if you do this, you're going to be a bit worried because California is very different from Kansas or from Arkansas or Missouri or whatever. And so these treated and control groups are not directly comparable. To deal with this, the synthetic control is going to create a fake California, which is a weighted average of the states that do not receive a tax on cigarette sales. But the weights are going to be chosen so that these states are going to resemble California. And then once you have this synthetic control that looks a bit like California and which is really a composite of like a number of different states and California, these composites and California look a lot more similar to each other. And when you compare their evolution through time after the sale tax is passed, then you can get at a treatment effect. And this is exactly what I do here, except that I don't have 50 units, I have 73,000 units, all the census tracts. And there is not just one unit that receives treatment, like California did in my example, but here more than 6,000 census tracts receive a map. And so I'm going to use a very computationally intensive approach to create for each individual census tract a composite of the census tracts that do not receive a digital map, but that looks very similar to the census tract that did receive the map. And similarity here is going to be based first on the number of insurance policies that are contracted in these tracts before the map updates, but also on other characteristics that we think might impact the response to the map update. And in particular, the share of pre-firm policies prior to the map update, the share of policies that are located in each different floodplains prior to the map update, and whether the census tract experienced a disaster in the past couple of years.
Mm-hmm.
I also have the math here, but yeah, I hope this helps.
Yes, that's very helpful. Thank you. The other thing that I had a question about, if I could ask one more, is on the two scatter plots, the purple and pink scatter plot. It seemed to me that, I mean, that the primary, like they're both positive relationships, but there's definitely a steeper relationship, right, in places that have had disasters more recently. Is sort of the recency effect? Does that come into play here at all in your analysis?
Yeah, so that's a really good point, and yeah, I do agree with you. The relationship is slightly steeper, but it's not hugely different. And if I regress the treatment effects on a bunch of census tract level characteristics, among them whether there was a disaster declaration in recent years, but also property rezoning, income, share of African Americans, etc. This relationship does not appear to be really different between the census tract that receive a disaster declaration and the census tracts that did not.
Okay.
But I still think that there could be a salience effect. It's just that I'm not picking it up statistically.
Yeah, I don't think Carolyn's on. I was looking at the list, but she did some work around uptake and intended to follow disasters, especially in areas outside of special flood hazard areas. So there probably is some initial response, but it doesn't look like it holds in too dramatically here in terms of the different relationships.
Yeah, there may still be something if we focus on, maybe if we look area by area, like by FEMA region, there might be something there. And yeah, I need to do a bit more work to investigate.
Sure. Yeah. Any other questions from other folks on the call?
Yeah, I had a question actually, if you don't mind.
Mm-hmm.
I thought it was really interesting. Thanks so much, by the way. This was great. Your point about, I think it was the African American tracts had a larger number of properties removed from the floodplains. I'm just wondering if you have greater kind of ideas about what was causing that, why that happened. Is it, I can imagine like they were getting more early adaptation kind of actions, or were they disproportionately high prior for some reason? I don't know. If you just talk a little bit more about that, I would appreciate it. Thanks.
Yeah, that's a really great question. Thanks for asking it. And I can show a bit more results since we have time here. Okay, so that's a complicated plot. So I figured it would take me too much time to go through it. But okay, so on this plot, I'm showing the share of properties that are rezoned outside of the 100-year floodplain on each of the x-axis here. So it goes between -1 and like, yeah, almost +1 in most cases. And on the y-axis here, I'm showing the log of the number of insurance policies in the census tract before treatment, just to get a sense of whether these are census tracts with a lot of insurance policies before receiving their map versus census tract with very few insurance policies. And so here, if you take the exponential of 6, that's about 1,000. So these are places, census tracts, where there were more than 1,000 insurance policies contracted in the census tract prior to receiving the flood map. Each dot is a synthetic control estimates at t plus 24, so 2 years after treatment. And I'm showing in red the treatment effects that are negative, meaning decrease in the demand for insurance 2 years after treatment as a result of the new map. And in blue, the ones that are positive, so an increase in the demand for insurance. And so it looks a bit like the French flag, and I'm sorry about that. But so I'm separating all these estimates in a bunch of different groups, in 8 groups to be exact. On the first row here, these are all the census tracts where the map decreased the number of properties located in the 100-year floodplain. And in the below row here, like you have all the census tracts where the new flood map increased the number of properties on inside of the 100-year floodplain. The columns show the quartile of the African-American populations in the census tract. So these are census tracts that are relatively mostly white population. And this is the top quartile of African-American population. So these are the census tracts with majority of African-Americans. And you can see that all the red dots, so all the negative treatment effects, are concentrated here and like here too. So really in places where there is a lot of African-American households, but all of these are really in areas where there was decrease in the 100-year floodplain. So that was like more addressing the first part of the question, just the descriptive fact that yes, these treatment effects are negative, but mostly in African-American quotes neighborhoods. Now, the second part of your question was, why do we observe this rezoning in the first place? Why do we observe so many properties that are removed from the 100-year floodplain in these areas? I don't have a definitive answer because it's really hard to get at causality here because there are a lot of different census tract characteristics that can influence whether they get rezoned inside or outside of the 100-year floodplain. But what the flood insurance studies say, like the documentation that go along with the new maps, and I looked at several of them, they always say that these rezoning were warranted because of like additional adaptation structure, as you hinted at, like pump station, floodgates, drainage systems. In particular in New Orleans, that there were a lot of investments in these post Hurricane Katrina. And in a minority of cases, they say that, well, we had to rezone properties outside of the 100-year floodplain because the previous map was incorrect. And so we corrected that. And now these properties are outside of the 100-year floodplain. When I compare, if I look at were these rezoning warranted based on the First Street Foundation flood model by quartile of African-American population share, it does look like the in this quartile, most of the rezoning were warranted, meaning that a lot of the properties were initially in the 100-year floodplain on the old map. They were removed on the new maps. And the First Street Foundation flood model says that, yes, these properties are not in the 100-year floodplain. So the big question then is, well, why were these properties in the 100-year floodplain in the first place for so long, and were only rezoned outside recently? Like, for instance, for New Orleans, a lot of the properties were in the 100-year floodplain since 1984. They were removed in 2016, and that came after Hurricane Katrina, but they were still in the 100-year floodplain for a very long time, and these homeowners and renters were paying higher insurance premiums. So yeah, I don't have a definitive answer on that, but if you believe the First Street Foundation flood model, which I do, then these reasonings appear to be mostly correct.
Thank you.
Yeah. But yeah, I think that's one of the questions where more work is needed, and so yeah, I'd love to get other people's feedback as well. Someone had another question?
Yeah, I had a question when that kind of near the beginning, when you were talking about the ways that you address the two-way fixed effects regression problems. You talked about that you used controls for cohorts as well as what specifically happened for each treat, or like which treatment direction kind of, or change.
Yeah.
For the cohorts, was that based off of the time of the treatment? Sorry, I might have just missed when you said that. And then what was kind of the time range for each cohort?
Yeah, that's a great question. So yeah, these issues with two-way fixed effects estimates, they arise, like, to have issues there, you need to have two conditions need to be verified. First, you need to have a staggered treatment, which means that different units get treated at different times, which is the case here. Different flood maps, like different census tracts receive flood maps at different times. But you also need to have a heterogeneous treatment effect between cohorts, where a cohort is defined as the group of census tracts that receives treatment at the same time. And in my case, treatment effects are very likely to be heterogeneous because the census tracts that received their flood maps first tended to be mostly digitization, whereas census tracts that receive a flood map later tended to rezone more properties outside of the 100-year floodplain. So the solution in, like, there were several papers, like theoretical econometrics papers that discuss these problems, and all the solutions so far involved estimating like simpler difference in difference estimates for each cohort. So you don't look at all the treated census tracts, but you look at all the treated census tracts that are treated at the same time. So same time meaning here month and year. I'm showing here 9 cohorts only, and I definitely cherry picked these out of 114 cohorts I have. You can look at the paper. I'm showing a picture with 45 or so different cohorts, but it's really hard to read. So here you have 9 cohorts. These cohorts, these are all the census tracts that are treated 8. So that's August of 2008. Here I'm showing the census tracts that received their digital map in January of 2012, and here in October 2017. So really different treatment groups. The control units in all these cases are going to be census tracts that have not yet received their digital map. And I'm going to estimate the effect separately for the blue and the red treated units. So blue are the ones where the new map shows increase in the 100-year floodplain. Red are the ones where the new map show a decrease in the 100-year floodplain at the property level. And you have the average treatment effects on the y-axis. And what's already apparent here is that within cohorts in general, when you have decrease in the 100-year floodplain induced by the new map, in red, you see decreases in the demand for flood insurance. Whereas for the same cohort, when you have an increase in the demand, in the number of properties zoned inside the 100-year floodplain, you see this uptake in the demand for insurance. There are some exceptions. I'm showing one here, like these for in September of 2010. These census tracts in red received a new map that showed less properties zoned inside of the 100-year floodplain. And for these census tracts, I still estimate a small but positive treatment effect, which is much smaller than the census tract where the new map showed an increase in the 100-year floodplain, but that is still positive. But this is basically the way to deal with this two-way fixed effect issue. You have to estimate the effect separately within cohorts and then reaggregate everything. The only thing that I do slightly differently here is that I don't do just within cohort, but within cohort, I also separate increases in the 100-year floodplain based on the new map and decreases in the 100-year floodplain. Does that answer your question?
Yeah, definitely. Thank you.
Yeah, thanks.
Any other final questions? All right. It's an excellent presentation. You're on the job market now? Is that what you said with this paper?
Yeah, I'll be looking for a job.
Excellent. It's a good. Mark, I don't know if there's any other announcements coming from the Flood Lab.
No, just that we'll be emailing everybody after this, the workshop recording and the slide decks. Joe, if you could send me your slides, I can send that to everybody. And if anyone has any first related questions, they can email me. And if they have questions about Joe's research, I can forward Joe's email as well.
And Joe, if there is a paper, a working paper or anything that you can share with this, that'd be great also.
Yeah, there is one. I posted one on my website. Yeah, I can send the link to Margaret.
Terrific. Yeah, we can send it out with the workshop recording. That'd be great.
Yeah.
Cool.
Yeah. Thanks a lot for your time and feedback.
Yeah. Great.
Thank you.
Thanks, Joe. Yeah.
Thanks, everyone.